Dear students, welcome to the fifth session of 6th online class of Maths, Unit 3 Variations, and for today the topic is Direct and Inverse Variation. Variation means change or vary. It means that how a quantity varies with respect to the other quantity. There are two types of variations, direct variations and inverse variation. Direct variation. If two quantities are related in such a way that increase in one quantity causes increase in the other quantity, or decrease in one quantity causes decrease in the other quantity, then this variation is called direct variation. Here we have some examples of direct variation, that if you buy more pens, so cost you more. If number of students are more, then more numbers of teachers will be required. If you travel less distance, then the time taken is less. If number of books are reduced, then weight of the bag is less. Next is inverse variation. If two quantities are related in such a way that when one quantity increases, the other decreases, is called inverse variation. For example, when you travel to a particular location, as your speed increases, the time it takes to arrive at that location decreases. Of course, if you increase your speed, then it will take less time to reach that location. If you decrease your speed, so it will take more time to reach that destination. In direct variation, we can express the relationship between two quantities in this form, that y is equal to kx, where k is the constant of variation. It will show that what is the relation between these two quantities. Suppose if the value of k is 2, so it means y is twice of x. If x is 1, so y will be 2. If x will be 2, so y will be 4. If x will be 3, so y will be 6. It means the constant of variation is here 2. In inverse variation, we can show the relationship between two quantities in this form. Y is equal to k divided by x. Let's go with further explanation of constant of variation. Here k is the constant of variation. If the constant of variation is 3, so we can write the equation y is equal to 3 times of x. It means that y is 3 times of x. If x is 1, y will be 3. If x is 2, so y will be 6. If x is 3, so y will be 9. We can better understand it with the help of this table, that if x is 3, y is 6. If x is 5, y is 10. If x is 7, so y is 14. If x is 9, so y is 18. Means everywhere y is double of x here. As 10 is double of 5, 14 is double of 7. So the constant of variation in this table is 2. You can find the constant of variation by shifting x to that side of the equation, and here you can see that the constant of variation is 2. Since it is 2 everywhere, so therefore it is named as constant. We have exercise 3.2 here. The first question is that if y varies directly as x and y is equal to 8 when x is equal to 2, then find y in terms of x. First part is that we are going to find the relation between y and x, the variation between y and x. So what type of variation is given? Direct variation. So we can write here that given that y varies directly as x, so we can write y. This is the symbol used for variation, and this is x. In order to find the variation or the constant of variation, we are supposed to replace this symbol by equal sign, and we can put k here, as k is the constant of variation. Okay, here some additional information is given, that for finding y in terms of x, we can put y is equal to 8 and x is equal to 2. So we can put here y is equal to 8 and x is equal to 2. So 2k is equal to 8. Here 2 is being divided to that side of the equation with 8, and we will get 4 2s are 2 4s are 8. So the constant of variation is 4 here. Now it is must to put this constant of variation in this equation back in order to show the relationship between y and x, in order to show y in terms of x. So y The value of k is what? 4 and x. It means y is 4 times of x. If x is 1, so y will be 4. If x will be 2, so y will be 8. If x is 3, so y will be 12. So the constant of variation here is 4. Now we are supposed to find the value of y when x is equal to 5. Next part of the question. Here is y when x is equal to 5. Here we can go all this step again in order to find the value of y. Now, in order to find the value of y, we need the value of k and we need the value of x. The value of x is given and we can find the value of the value of k. The value of k is already found here. Here we are doing again for the second part. Means the same procedures are done here and we have the value of k is 4. So we can put in the equation y is equal to kx. The value of k is 4 and the value of x is 5. So the value of y will be 20. Here mistakenly 50 is written. You can rectify it. The next part is that we are supposed to find the value of x when y is given. So y is equal to kx, the same equation. Here again we can find the value of k, though it is found here. K is 4. We can go again for practice, or since it is the third part, so we can do the same steps again. If not, then it's up to you. And value of y is given here and we are supposed to find the value of x. Now the value of k is again found and we can put in the equation here. You can see y is 28, k is 4 and x as it is. So you can write this in equation this form, 4x and 28. 4 can be divided to that side of the equation, so 4 sevens are 28. The value of x is 7 here. Question number 2 is similar to question number 1, so therefore we have to move towards question number 3. If r is directly proportional to t and r is 5 and t is equal to 8, find an equation connecting r and t. This question have 3 parts. The first part is that we are going to find the equation which connects r and t. So of course the relation can be found with the help of constant of variation. So here we have the variation, direct variation between r and t. R is equal to kt. When we will put these values r5 and t8, so we'll get 8k and 5. So the value of k will be 5 upon 8. 8 is being multiplied here, so at that side of the equation it will get divided. Here's the value of k. Now you have to put back this value in this equation in order to show the connection between r and t. So let's put the value of k in this equation. So the relation between r and t will be that r is 5 upon 8 times of t. Now let's move towards the second part of the question, that also find r. Now we are supposed to find the value of r when t is given. Now see here, r is as it is, 5 upon 8 written as it is. Now the value of t is 64. 8 8 are 64 and 5 8s are 40. This is the value of r. Now we are supposed to find the value of t when r is given. Again in the same equation we can put r20 and now t we are supposed to find out. So here we can write this. If you can bring this to this side of the equation and you can write this to this side of the equation. Here we can see that t 5 upon 8 is with t. In order to find the value of 8, you have to shift 5 upon t to that side of the equation, 5 upon 8 to that side of the equation. If it will by shifting it to that side of the equation, let me rectify it, this is done wrong. So it will get reversed. 8 should be written first, in numerator, and t5 will be written in denominator. So here we can go with 5 4s are 20. If you just go multiply, 5 1 is 5, 5 4s are 20. So 4 with 8 will result in 32. Fine. Let's go with question number 4. If r is directly proportional to t square and r is equal to 8 when t is equal to 3, then we are going to find r when t is equal to 6. Okay, first of all, let's go with let's solve this. Means we have to find the constant of variation here, because it is given that r is in variation with t square. So we have to find that what is the constant of variation between these two values. then we can proceed ahead. Okay, we cannot proceed ahead until and unless the constant of variation is found. So let's write here that instead of variation we can write equal and kt square. Now we can put these values in this equation in order to find the value of constant of variation. R is equal to 8 and t is equal to 3. 3 3s are 9k, and the value of k will be here what? 8 divided by 9. Now we can put this k back in this equation in order to show the relation between r and t. Okay, next part is that we are going to find the value of r when t is 6. So let's put the means instead of t we can put the value 6 here, and we can go with the calculation. 8 4s are 36, and okay, here we can see that 5 upon 8 is done wrong. Let me rectify it. Here it must be written, it is 8 upon 9. This is wrong. So 9 1 is 9, 9 4s are 36. So 8 into 4 will be 32. This is the value of r. Question number 7 is that if y varies inversely and x and y is equal to is x and y is equal to 7 when x is equal to 2, find y when x is equal to 126. Just break up this question into different parts, then you can easily solve it. Let's just go with this part. If y varies inversely as x, means there is inverse variation or inverse relation between y and x, or we can say that y is inversely proportional to x. So y is inversely proportional is used by y 1 upon x, and we can write the constant k because k if multiplied by 1 will result again in k. So you can write k here in numerator. Now we are going to find first the value of k, means the constant of variation. So for that you have to put the value of y 7 and the value of x 2. So when 2 is being divided here, so it will get multiplied with 7. 7 2s are 14. So the constant of variation k is what? 14 here. So you can put this back into this equation. Okay, now next part is that find y, means we are going to find the value of y now. When x is given, the value of x is given 126. So y as it is. K we have already found, the value of k is 14, and instead of x we can put 126. 14 1 is 14 and 14 9s are 126, and this is the value of y. Question number 10 is that if a is inversely proportional with r square, then the value of a is 2, and when r is equal to 3 we are going to find r when a is equal to 72. First of all, let's find the constant of variation here. Okay, this is written in, okay, here you can write the constant of variation is k 1 upon r square. Then now you can put the values. A is equal to 2, and instead of r you can put the value here. Now 3 3s are 9 and 9 2s are 18. So the value of k will be 18 here. The k is found. Now we have to find the value of r when a is equal to, yes, okay, k is 18 and a is equal to 72, and we are supposed to find r. So if all of these numbers are present or all of these terms are present in this equation 1, so let's put the values here and we can find the value of r here. A is equal to 72, k is equal to 18, and r square as it is here. Okay, since you are going to find the value of r, so r should be at this side of the equation in constant terms or numbers at this side of the equation. 72 can be written here in denominator as it is in numerator here. So by calculation we will get 1 upon 4, since it is r square, so you can take square root on both sides in order to cancel the square, because you are just supposed to find the value of r. So you will be having plus minus 1 upon 2. This is the last question of this exercise. This exercise is very easy exercise. All the questions are similar to each other, so you can easily do the homework then. M is inversely proportional with n cube, and m is equal to 2 when n is equal to 4. Find m when n is equal to 6 and n when m is equal to 432. Let's break up this question in parts. First of all, till here you are supposed to solve, means before the comma. If m is inversely proportional with n cube, you can write here. Now you can just convert this symbol with the constant of variation here. K is equal divided by n3, and this is equation number 1. First of all, you are going to find the constant of variation till here by putting the value of m2 and the value of n4. 2 is brought down as it is, k as it is, and 4 when multiplied 3 times will result in 64, means 4 4s are 16 and 16 4s are 64. So 64 when multiplied by 2, because it is being divided here, so it will be multiplied with 2. So you will get the constant of variation is 128. We can put this back in this equation. Okay, now you're supposed to find the value of m, means value of m can be found from here. When n is equal to 6, and instead of n we can put 6 and then we can put q. Okay, then we have the value of k already with us, so easily we can find the value of m. Let's go with this. K is equal to 128, the same, and we are going to put these values here in order to find the value of m. 6 when multiplied 3 times, so 6 6 36, 36 again with 6 will result in 216. By calculation, you can use calculator here, or you can go with a cancellation here. You will get 16 upon 27, as it can go with the table of 2 because both of them are even numbers, so you can proceed. Okay, now this is the value of m. This is this part. After n, it means you have to go with the next portion of the question, and you are going to find n, means the value of n when m is equal to, now the value of m is given, so n also exists in this equation, so we can find the value of n again from this equation, having the value of m and k. So you can put here the value of k is 128, the value of m is 432, and n cube is written as it is. Now n3 will be shifted to that side of the equation because it is being in division, so it will get will be in numerator at that side of the equation. Okay, by simplification we'll get 8 upon 27, and now you can see that this is cube, so you need just the value of n, not n cube, so you will take cube roots on both sides. The cube of 8 is 2, when 2 will be multiplied 3 times, and the cube of 27 is 3. When you will take the cube roots on both sides, so it will get cancelled, and the value of n will be 2 upon 3. Okay, here we are done with the exercise. Okay, stay blessed. Have a nice day.